All right, we're going to review chapter 11 today. Good chance it's going to take 2 videos to do it because I'm limited to 20 minutes per video. Parallelogram was the area is the base times the height. This is an example of the parallelogram. Notice that I don't have the height of this. I do have the base, so I could go ahead and put in the 10 for the base. But I have to take this and find the height of it. So I'm going to take this triangle out. I know that this is 45 degrees and this is 8 centimeters. What I'm looking for is that part right there, which is the height of the triangle. So that's opposite and hypotenuse, so that's the sine. So I have the sine of 45 degrees is equal to opposite over hypotenuse. Well, to get the h by itself, I'm going to multiply both sides by 8. And I'm going to find out that the height is equal to 5.7 centimeters. So that's going to go up here, the 5.7. When I multiply that out, I find out that I have an area of this parallelogram of 57 centimeters squared. All right, now I'm going to have you try one. So I'm going to put it up there and you can pause the video and come back to it. We're going to try and do that each time, so hopefully this works out to help you review. I know some of the material in this chapter is kind of hard, so you just hang with it and do what you need to do. All right, go ahead and find the area of this parallelogram. I think I also know this. Okay, which means then this is that. Okay, so go ahead and try it and work through it. All right, so I know the base is 11. What I don't know is the height, so I'm going to pull the triangle out. So this triangle is this over here. This is 60. This is 5. I need to know the height, which is this. So I have the sine of 60 is equal to opposite, which is the h, over the hypotenuse. So h is going to be 5 times the sine of 60, which is 4.3. So I'm going to multiply 11 times 4.3 and get an area of 47.6 meters squared. All right, let's go on to another one where you have a combination of parallelograms. Might take me a second to draw this. Obviously not to scale, but 2, 2, 1, 4, 4, 2, 2, 2, 9, 2, and 1. Okay, 9, okay. What we have, this is probably how I would have find it. I would go ahead and do some lines there, and I would find these things individually. Okay, 1 times 2, that's going to give me 2 units squared right there. This one is going to be a 4, and I'd have to figure out what the dimensions across there are. So I've got 9 here. I'm going to subtract the 4, so that's going to give me a 5, and then I'm going to subtract the 1. Okay, so I have a 1 and a 4. It's going to come off of the 9 to give me a 4 right there. So that's going to be 4 times 4, which is going to be 16 units squared right there. This one's going to be 8 units squared. So far I've got all of these. And then down here I have a 9 times 2, which is going to give me 18 units squared. So I'm going to add up all of my circled answers and I'm gonna get a total of 44 units squared, and that's gonna be my area of this whole thing. Now there's other ways you could have broken it up, but to me that's the easier one. All right, that was section 10 or 11.1. Section 11.2 talks about the area of a triangle, trapezoid, and rhombi. Okay, now if you remember right, the triangle is 1/2 the base times the height. The trapezoid is 1/2 the height times b sub 1 plus b sub 2. And the rhombus, which is like a diamond, if you will, that all the sides are the same, that's not a very good indication of one, is 1/2 d sub 1 times d sub 2. I hope you can see that in the picture. All right, so hopefully you understand on each one of those. And here would be an example of one of these. When you go to do your review homework, I know you're going to have some of each, so hopefully, and just text me if you're confused on any one of them. But here's an example of some of these put together. Not drawn to scale, but it's all right. All right, let's say I want to find the area of this whole thing. What I would do is I would separate this into two triangles. I would probably do this triangle and that triangle. And on this one, the area is equal to 1/2. The base would be 20 plus 20, or 40, times the height, which would be 56. The height is always perpendicular to the other side. This one would be 1/2. The base again is going to be 40, but the height here is going to be 26. So when I do that out, I'm going to get, this one is 1,120 units squared. And this one is 520 units squared. And I'm going to add these two things together and get 1,640 units squared. All right, now I'm going to put one up there for you to try. That's a right angle right there. All right, find the area of that whole thing and then come back to the video. If I'm going to find the area here, it's 1/2 the base, which is 33, times the height, which is 20, which is going to give me 330 units squared. This one right here, this is the base, and this is the height, because that's a right angle. So it's 1/2, 16 times 21, which is 168 units squared. When I add these two together, I'm going to get 498 units squared. And that should be your answer. All right, section 11.3 was the area of a regular polygon or circle. This is where it started getting a little harder because it threw in the apothem into the mix. And if you remember right, any regular polygon, the area is 1/2 the perimeter times the apothem, and on a circle, the area is pi r squared. So, say I have a regular hexagon. Regular means that all the sides are the same and all the angles are the same. Let's say I know that the perimeter of this is 84 units. Okay, Okay, I can use that to find what each of these sides are. And if you remember right, any polygon is made up of regular triangles, if it's a regular polygon. So when I divide the 84 by the 6 sides, I find out that each side is equal to 14. So 14, 14, 14, 14, 14, and 14. And of course I already have the p part, so let's go ahead and put in what I've got. The perimeter is 84. What I don't know is the apothem. The apothem is a line that comes down from the center that's perpendicular to one of the sides. And remember, it bisects the angle and it bisects the side, okay? So that's what I'm still trying to find. What I have to find here first is what each of these central angles are. So I have 360 divided by 6, so each of those central angles is 60 degrees. Okay, now I'm going to pull out this one particular triangle so that we can work on it. Okay, I know that that angle is 60 degrees, and I know that this is 14. The apothem cuts this thing in half, which means this angle over here is 30, this angle right here is 30, this is 7, and this is 7. The apothem is that part right there. So if I'm standing here, I've got opposite and adjacent, which is tangent. So the tangent is opposite, which is 7, the tangent of 30, I'm sorry. The tangent of 30 degrees is opposite, which is 7, over the apothem. So I'm going to multiply both sides by a to get the a off the bottom. So I have a times the tangent of 30 is equal to 7. I'm going to divide both sides by the tangent of 30. And I'm going to find that the apothem is equal to 12.1. Well, that's what's going to go up here to allow me to find the area of 508.2 units squared. And that's the area of this hexagon. All right, the circle, remember, is your pi r squared. Now we didn't really work too much with just regular circles. We combined the circles with something else, which is what made it a little bit harder. Well, let's say I have a triangle. Oops. And I know that the distance from here, perpendicular to the side, is 9 meters. Well, and all this part right here is shaded. So my plan would be to take the area of the triangle and subtract the area of the circle. The circle is the easiest thing to find, so the circle is going to be pi times, and this is, if you notice, that's the radius of the circle, so pi times 81, because it's 9 squared, and that's going to give me an area of the circle of 254.5 meters. Now, meters squared. You might be off a little bit on your numbers depending on where you round it, so as long as it's close, you're all right. All right, now I've got a problem with the triangle, because the triangle, I've got to know the base and the height. So what I'm going to do is I'm going to go ahead and pull out one of these triangles. Okay, so if I pull that out, I know that this part is 9 meters. Okay, I also know that this part over here is 30, because what I've done is, this is a regular triangle, so each of these corners is 60, which means that's 30 and that's 30. All right, what I need to know is the base of that triangle. Well, actually, yeah, let's do it that way. I need to know the x part, which is going to be this right here, so then I can find all of the sides, okay? So I'm going to go the tangent, because I'm standing here, the tangent of 9 over x, because x is right there, x is also right there, it's half the side. okay, the tangent of 30 degrees is equal to 9 over x, so x is going to give me 9 divided by the tangent of 30 once I work it out, which gives me 15.6. So this part right here is 15.6 and this is 15.6, okay? So the entire side then is going to be 31.2. Okay, well now that's easy for me to find the perimeter. But it's also, it might be easier just to do the base times the height on this triangle rather than the apothem one. So let's do that. I know the base of this is 32. The height of it, I can easily get. So I have 15.6 here. I already know that this out here, so I'm right here, 15.6, and I already know that this is 31.2 right here. So I can use the Pythagorean theorem to find that. When I find that, let me get a calculator. So I have got x squared plus 15.6 squared is equal to 31.2 squared, because I've got the base and I've got the height, and what I did is I'm just looking at this particular triangle right here in order to get the height. Okay, so that's going to make the bottom 15.6 and the side 31.2, which is going to be my hypotenuse. So I've got 31.2 squared minus 15.6 squared, and I'm going to take the square root of that, which is 27 point, well, it rounds to just 27.0, okay? So the area of the triangle is 1/2 the base, which is 31.2, times the height, which is 27. So 0.5 times 31.2 times 27 gives me 421.2 units squared. And I'm going to subtract that from my circle, which is going to give me an answer of 166.7 meters, because it's meters, not units, meters squared. All right. All right, let me put one up there for you to try. All right, go ahead and give that a shot. Develop your plan and then go forward with it. I'm going to do it on the video, so pause the video and come back to it. My plan is circle area minus hexagon. So it's going to be that formula minus this formula. The circle, again, your radius is 25, so it's going to be pi times 25 squared, which is going to give me 1,963.5 feet squared. Hexagon is a little harder, but you know that it's made up of triangles. So I'm going to just pull one of those triangles out. My hexagon will be this line right here, okay? Or my apothem, not my hexagon. My apothem is that line right there. But in order to know the perimeter, I've got to find this side as well. So I'm going to pull out this triangle. I have 360 divided by 6, which this makes that whole thing 60, so part of it is 30. So I'm just going to pull out that part right there. So this is 30, this is A, and this is 20.